Alrighty, here we are. Parameterized. All right. Spelling that wrong? I'm not sure. When does the waiting room vid start having sound? Well, it'd be pretty soon, shouldn't it? We're like a minute and a half in. Maybe it actually doesn't start. Wow, really ought to have some kind of sound. I guess they call that dead air. Dead air is a bad thing, right? I'm not sure why this goes so long, unless, of course, I have the. No, I don't think so. There it is. Oops. Not sure why. What window I'm supposed to be. Oh, that's right. I'm supposed to pop out the chat window. There it is. Pop it out. Okay. And then we'll have a link that we can pick. Somewhere here. That one? think so. It's Mozilla Firefox. Well, that's a great name. And great. I can't find it. And I move it back to the main video screen, maybe? No. Ah, there it is. That's it. Now why? Why it's also saying chat disabled. Oh, I guess it's that. All right. Okay. Well, let's pretend that's gonna work. So sorry. Alright, we loop back to the beginning on our video. I think we are set. It looks like I have the microphone unmuted. Good for me. We shall see what we shall see. Thinking about going to, live recorded TV shows where they have a comedian that comes out before the show begins to get the audience pepped up. I have the diamond cells reproducing. It's time to focus here, Dave. Stay with it. Hey everybody, it's T2sday. It's April 1st. These were the goals for this time. I've learned to lower my expectations, make something do something by itself, and have big fun. That was it. I am declaring big yeses for both of those. I've got a tremendous amount of stuff I want to talk about. This update may run a little long. Maybe it'll even go 20 minutes. We'll see. If I get hung up on something, we'll see how it goes. So I want to talk about development and community in particular, and then planning can get short shrift at the end. I mean, the planning is still FPGA or TensTorrent. TensTorrent still kind of has the edge. So let's start the development by taking a look at our only Beevee episode. Sort of a review. And one thing to do is to sort of keep an eye on the brains in the upper left, even if they don't make any particular sense. Since we're starting almost 3 months ago, the blocks move around, the connections change, and so on. Successful hard-coded Beevee action programs like Spiral. It's particularly spread out in this era. Gets a little more packed. Yeah, there it is. It started to get more packed together again. Started trying to get as much stuff packed into the hotbox tile to reduce the amount of axons, those lines, to make the signals move a little faster. I don't know how much difference it made. Yeah, we're less than a week ago. Look at this. Now there's a display. It doesn't display anything useful really yet. And here's Beevee's big success. Last attempt to get localization working before today, it did not work. There was a bug which I have since diagnosed, but have not yet seen how much better Beevee manages to do with the bug fixed. That'll be for the future. And that is that. So that's where Beevee's at. A lot of the action all along has been breeding development, but let's take a look at what's going on there. So, did we achieve localization? Did Beevee know where it was on the grid? No. Was there progress? Oh, yeah, there was progress. A whole new stack, I said, right? 5 years ago, 2018. Oh my God, 7 years ago now. We need a whole new stack. So it begins with what we're calling ISAC, indefinitely scalable array of asynchronous computers that indefinitely scalable. You can keep plugging them together. The movable feast machine is an example of ISAC. It has sites with atoms and event windows that leads to the programming language Ulam, which has physics to specify how the transition functions between event windows happen. Then it leads to all the user program stuff that I've been working on for the last several years, the grids, crossbars, axons, sensory motor taps, and just in the last couple of months, a PID controller, a proportional integral derivative controller, which is a very well known and well-studied system controller for controlling robots and factories and rice cookers and so forth. We have implemented one in ISAC, and this is the idea. There will be related tasks that we will implement in related ways, but we're trying to learn the advantages and disadvantages to spring the design bear traps and so on. Now we're on to grid navigation, localization, figuring out scale so it can tell where it is on the grid and so on. There is 13,000 lines of Ulam code in the Beevee 2025 repo now, not including another 2,000 lines that are auto-generated, and it has been bug city. I mean, more than that, it's the entire bug metropolitan area and so forth. And I think, I've had all kinds of flags here and there. Are we in the middle of a turn? Well, then don't do this. Make sure you do that twice. No idea what was going on, and typically didn't know what was going wrong when things were going wrong. Took a tremendous amount of debugging. And I decided what we need is a whole new language. When you got a problem, when you get too much complexity, what you need is a whole new language that will make certain things easier and certain things virtually impossible. And it's the virtually impossible that we're looking for, so that we get rid of whole classes of bugs, because you have to do it in this particular stereotyped way. And the language I came up with, I call NAFI. NAFI is not a fourth interpreter. I'll talk about what that means. But there's a little example of the code, and here is a little the metropolitan area, and that little dot right there is a NAFI interpreter. And so NAFI is not a fourth interpreter. Fourth is a programming language from the 70s, developed by Chuck Moore and then a bunch of other people. And it's been sort of a niche language, but it absolutely real, absolutely going on the whole time, even though it was never a star language like C++ or Java or Rust or what have you, or of course Python. Relative simplicity of creating a basic fourth led to many personal variants. used to implement video games, used in spaceflight applications, and in other embedded systems which involve interaction with hardware. This is the Philae spacecraft. Fourth has landed on a comet. Can your programming language say that? That's pretty damn cool. That's interacting with hardware. So how does Forth work? Well, it's basically a stack and a RAM and a program counter all wrapped up together in very cool ways to do very cool stuff. So for my purposes, interaction with hardware, well, Beevee is our hardware, even though it's simulated. One of the things people have often suggested, why not change the hardware to do whatever to get around problems in the software development? And I've been reluctant to do that because I want to take Beevee as the hardware. It's sort of as given, and we have to figure out what we can do with what we got. Now, I started programming around 1973. Forth came out around 1970. In those succeeding 50 years plus, I have never implemented a Forth of my own. And I still haven't, because NAFI is not a Forth interpreter. So, but there's a question for the insiders. How could MFM and Ulam support a Forth-like language that needs stack and RAM and PC program counter? Because MFM has no RAM. All you have is these little event windows that have a very limited state, about 1,000 bits, or I'm sorry, I guess it's about 4,000 bits, something like that. But very small, and no general purpose RAM accessible at all. Well, MFM can support a Forth-like language if all the code is constant. Now, Forth purists at this point are just going, it's no fun, because changing the code as you develop it is an inherent activity in the Forth system. But here it is, constant in, contents of RAM, 186 ints, off it goes. And as long as the code is constant, then all we need is the stack and the PC. And we can make it very small. For example, I made Atom NAFI, which is the stack and the program counter in one atom. So we have a 10-bit program counter. That means it can access 1,000 words of constant RAM, of cram. We don't have that much in it, but I had room to grow. And the stack is 6 entries deep, and here it is, like I pointed out before. That little white square is an Atom NAFI. The PC is currently at 132. Here's the stack. The stack first free is 3. That means the top of the stack is 2. It's got a 6 in it, and then below that there's 107. Below that there's a 92. It's executing. And this is all part of that whole region. GTCC and Loxy are the stuff hard-coded stuff I wrote that was doing speed control, the PID controller, and all those various kinds of things, tracking the changes in the grid going over light and dark patches on the floor, and so on, that are all mutually accessible in the same event window as the Atom NAFI, and HDT8 is the truck driver that's in charge of the whole thing, and it has actually very little stuff in it, because mostly it just dishes to Atom NAFI to say, do whatever's next. And that whole thing is, this tiny little spot in this brain, which now, like I said, has a display. This is actually retooling a font demo that goes all the way back to when I gave a talk at the University of California, San Diego, where I met, Andrew and I crossed, and now it's part of Beevee's brain. Beevee cannot see the display. It's just debugging for me, but it's useful to pull it all together, both for that purpose, because eventually I still have ambitions to do a beer world model up there. Oh, and, while I was setting up this diagram to take these screenshots, I did some time travel debugging that you can do in the simulator on the hotbox tile here. And then when I restarted it, I didn't get back to the present. So MFM detected a whole bunch of cache inconsistencies between what this tile thought and what the neighboring tiles thought was going on. So, errors, a whole patch of errors that led to a whole bunch of stuff being erased. Beevee didn't notice it at all. You cannot see any. It wrote it out. This is what it's like building on a robust first architecture. All right. Oh yeah, there they are. NCC's inconsistent cache contents. So how does Nafi work? Yeah, we're gonna go to 20 minutes. Take all the behaviors that I had hard-coded for demos before, give them all names, give them numbers, make a configuration file that says, well, how do you do dress line forward? Well, you need to go slow because we're trying to stay right on the line and know where we are. So max speed 3, min speed, and all we need to say is motor controller parameters. This is one of the ways to specify it. And then when we're done, and so then the motor controller will go off and do all that stuff independently. And when it detects the done function has become true, that's a Nafi function. Here's the code for it, same edge. So check the front clock, call a function to check the front clock, check the rear clock, see if they're equal. And, you know, that's kind of weird. I can't. Oh, right, yeah. Front, rear, front operator again. Okay, so there are equal and. I thought I had a bug there. And so forth. And here is the faced east spike, which in fact is what we saw running on the yesterday portion of Beevee's adventure. Call a function to face to the east, turn left, here's dress line forward, call run tracked on it, and so on. This is the entire code, which isn't working. Moment to do this. There's a similar one for trying to find the origin as a beginning process of localization, but it's not working yet. Localization achieved, no. Progress, oh yeah. Okay, community. Curious Reader and Andrew at the Discord. That's like a Star Trek Next Generation. You know, it's metaphor. Curious Reader has been a long time participant in this project and in Dave Ackley stuff and so on. And, you know, in March, it's this time of a year where I ask again to try to understand it. So hardware and software. Software expects hardware to be deterministic. And of course, that's one of the things we're requiring programmers, developers to give up in order to move to Isaac, in order to move to indefinitely scalable asynchronous computing. And Curious Reader also connected to Andrew with a plug for Andrew's blog post, Introduction to Robust First Computing. I second this support. It's great. It explains it much better at a much more simple and gettable level than I have been able to do because my brain is too warped from having done it all. And Andrew chimed in response to Curious Reader. The perspective to build up in your head, which hopefully isn't too disappointing, is that 80 years of traditional computing, but down in robust, we're still just doing the equivalent of beginnings. And that's absolutely right. The atoms are appropriate names. Super simple. But focusing on doing useful stuff is good because it puts the whole thing into the context of a system. Are you doing something useful? When Dave references building bottom up, he's saying start with the system and build up from there. The other point is to mention that MFM and T2 tiles are not necessarily the be-all, end-all of the way Isaac and robust first and indefinitely scalable computing will necessarily be done. Exactly. Yes. It's just what I could figure out to do to try to start exploring the whole architecture space, the architectural family, to push hardware and software into robust for territory. And they went back and forth. I really recommend, if you can stand going on Discord, and I avoided it for a long time, but there we are. It's, you know, the T2 Tile Project Discord channel is very quiet. So the announcements and a little chit chat like this is a big event. So my thoughts following up on this. So one of the things that Curious Reader was saying was, you know, can we expect to have like an 8086 processor CPU built in MFM or even something simpler? And, you know, my suggestion is that's not what we should want, because an 8086, yes, it's small, yes, it's simple, but it's still CPU and RAM. And my suggestion is robust CPU RAM is an oxymoron. It doesn't make sense. That CPU and RAM is never going to be really robust. You can try with all kinds of things, but it's not going to work. So I think instead of thinking, I'm going to wait to do robust first until they can give me a processor that's essentially deterministic and I can keep on playing like I have been before. Instead of thinking that way, think FPGAs, field programmable gate arrays, which are a spatially distributed array, but in an indefinitely scalable way. FPGAs can have soft processors, they call them soft cores, but that's not why we use an FPGA. So if we wanted to do an 8086, there's a thing called the microblaze, a very simple CPU processing that you can just plop down on an FPGA and it'll take up a certain amount of the resources and so forth. And that's great because you need sequencing. CPU type stuff is for doing sequential stuff, but you want to do as much as possible distributed, as much as possible in parallel. And that's what scalable architectures, that's what spatially distributed does. Think systems first, think bottom up. Thank you, Curious Reader and Andrew. I don't know how much time I've got to keep working on this stuff, and hearing other folks saying the thoughts back to me and having them make sense to them. Thank you so much. All right, so the planning, let's skip it. We'll talk more about it next month. Again, it's what can we do for the second half of this year, and I'm thinking maybe try to do some spikes about how speeding things up. So the goals for May 6th, okay, Localize. I am the boy who cried Localize, but I feel like I'm so close. I almost thought I was going to get it for here. Also want to pick a notebook research topic. Haven't done a research notebook video over on the Dave Ackley channel for a long time. Any suggestions there would be great, and have more big fun. Thank you so much for taking a look. I hope to see you next time. Alrighty. So I went 20 minutes. Sue me. But everybody says, the YouTubers say, as long as you've got content, you should go as long as you've got content. And I was packing it in there. So can we check in on the chat, see if anybody said hi? Oh, apparently not. Oh, fudge. Chat and me is not doing it. Why not? Oh. Well, so, well, we've got some folks that have stopped in. Thanks, everybody. Maybe if I move it over to the other window, I could do it. Oh, in fact, there it is. Yes, I see. Now that I'm here, we've got it. Foib, hello. Hello, Foib. Have we met before? I'm not sure. Parameterized. You've checked into the Discord, right? And all right. Well, so anyway, it was fun. So I guess again, following up on Curious Reader and Andrew's discussion, that implementing a PID controller and now implementing a stack-based sequential language, I think thinking that sort of robust FPGA, robust scalable FPGA seems like a good way to go. And so Adam Naffy is a soft core. It's a very tiny soft core, not like the Microblaze, which is the soft core from Xilinx, which is now owned by AMD. Great. Uh, um, you won't go that far wrong if you think about potato. Hi, potato. Uh, 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 Thinking in terms of imagining an FPGA that's scalable. Now, the reality tends to be that FPGAs in the real world are mostly used, I was talking about this on the Discord, I think, mostly used for prototyping uh, things that are going to be made into chips later. For example, the TENS torrent wormhole, black hole, grayskull chips that I'm considering acquiring for the second half of this year to experiment with trying to get a version of MFM style architecture running that could take advantage of 96 core parallelism or even more than that if we go with wormhole and so on. What is the video about? Well, you mean the research notebook video, Potato? That is the question. I mean, it doesn't exist yet. So I think about things like indefinite scalability. I mean, the research notebook things I mean, people seem to kind of enjoy them. They get a chunk of views. They don't get nearly as many views as the tutorial stuff on the Dave Ackley channel. The stuff about pseudo random numbers, evergreen. It's up to 70,000 views or something now after a zillion years, because it's broad appeal. Lots of people know about random number generators, pseudo random number generators, or want to know more. As far as I can tell, primarily because of Minecraft, which is great, and so on for the other things. But I've did a robust local synchronization research notebook video. The original Demon Horde sort that in many ways is what a lot of people have seen. The first thing people have seen about the movable feast machine architecture was a research notebook video where the point is it's not just to report my latest research, which is what the T2sday updates are about, research and development and community outreach and so forth, everything. But to try to make it a little bit more tutorial. And I tried to do that today to give a little background on Forth before explaining why Nafi is not a Forth interpreter and so on. But usually I don't have enough time because I'm hacking until the very last minute. So the slides and the update talks doesn't get a lot of polish, and I'm sorry about that. But thank you. I mean, for checking in anyway. So we don't know. If you're talking about the research notebook video, we don't know. Oh, there you go. Foib says the random number generator video was how I discovered my channel, how I discovered the Dave Ackley channel. Like that. And yeah, I mean, I think that video came out really well. Not to blow my own horn too much, but there's a lot of confusion about random numbers, and I welcome Potato, and thanks for coming by. Thanks for coming by live, and thanks for speaking up. It just really helped for me to know there's people out there that in principle, we might chat with, we might interact with, and so the random number stuff is. There's philosophical questions about what does randomness really mean, and does randomness really exist, and does the only randomness come from quantum stuff, and so on and so forth. And I really think that a lot of the standard assumptions about randomness that they're one way that you can look at it, but they are kind of exclusive. They kind of say, no, this is it. This is fact. This is what randomness is. And I think that's not true. I think there's other ways to look at randomness. And I mentioned one in the pseudo-random number generator video on the Dave Ackley channel, another perspective where it's a cognitive statement about our minds and our brains about how we are looking at the world. There are things that we call random, and that's the most important part of it. It's that we label them as random, not that they are quantum blah 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 or anything. And in fact, what one person labels as random, another person might not. If they have studied the particular thing in more detail and they understand the interlinked workings, then they might be able to make better predictions than the person who's thinking whatever it is random, so it's going to be whatever it is equally likely. This other person who understands the mechanism inside is saying, oh, it's not equally likely. I'm going to make money off of the other guy or whatever. High speed. Now that Beevee almost has yeah, exactly. What's the ETA on a logo turtle implementation in Nafi? Yeah, exactly. Another person was saying a similar sort of thing. It looks like, turn right, go forward, all that sort of thing. It does. It is. So how much can be crammed in there? That's a good way to put it. A constant array in Ulam can be 8K bits long, which is, I think, 256 ints if they're full size int 32s. So that means that the obvious way of representing the code could be can only hold 256 instructions. But there's no reason why we couldn't break that down and have multiple int arrays that and have the PC just go off, index from the bottom of one to the beginning of the next, and so on and so forth. So we can basically have as much constant code as we want. Can spare space in the tile layer be used for Gestalt qualia? I am not sure what that means. There's 71 bits per atom. There's a little bit of extra stuff down in the sites that doesn't move with the atom that can also be used. What it would mean to use that for qualia, I'm not sure. Basically we need to build a lot of stuff before I would even be able to think, oh, well, that's something that might be like a qualia, that might be a representation of the redness of the void, the warning track. I don't know. Gert Tractor, Gert Tarkter. I've been saying tractor. I've been writing tractor all month long. Randomness is observer dependent. Yes. Thank you. And that seems so outrageous when you think that randomness is this inherent property of the physical world. And I think that's really not the only way, and I think maybe not the best way to think about it. Potato, sorry to disturb me, but do we talk about technology? We absolutely will talk about technology. I mean, the idea of hanging around after doing the T2sday update officially to anybody who's here is it's kind of like, what shall we talk about? I'm open. So what kind of technology might you be thinking of talking about? I'll probably be into it. So it is tractor. Well then, and now it's been Tarkter for a decade or whatever. I think technology. I think almost everything is technology, right? So the big umbrella for me is living computation. And the first take there is that living systems and computational systems end up being the same class of systems. They're two different takes on the same thing. So I'm a machine, you're a machine. Everything that's living is a machine, and everything that we would think is that is a machine that isn't living. The reason those machines, like say computers, exist is because living systems ultimately built them. So it's not about intelligence or whatever it is. Yes, it's about computational paganism. The way that we want to look at things is saying anything, anywhere we see in the world where it looks like a system is trying to preserve itself. It's consuming energy to preserve itself. My standard example is a little eddy, a whirlpool in the stream. The water flows by, it spins around. That whirlpool is so fragile, but it persists. You see it moving over time. That, according to this view, that machine, that little whirlpool, is a very simple, primitive, computational, little bit kind of having a little bit kind of life. And so technology is, life carried on by other means, right? We use our hands to gather sticks to build a fire. We, rub sticks together to make friction to start a fire, whatever it is that we do. That's taking the hardware that we control and using it to make changes in the world around us to make things better for us, in particular to allow us to preserve our pattern, to have a nice cooked meal or what have you. More about smart TVs and coding. Okay, parameterize. Making computers is kinetic non-self reproduction. Kinetic non-self reproduction. I mean, sure, I can go with that. I mean, making computers is like making any other kind of machine. Making a computer is like making a hammer that we can then hammer things with it. It's additional. It's taking physical matter that's arranged in some general purpose way and arranging it in a purpose so that it'll do something for us. It'll do something that we want. And computers are an example of that. So, kinetic meaning moving. I mean, I do believe that the clearest way that I can think of to think about what a machine is, it's an arrangement of matter that has some kind of power source so that it actually does something, whether it's a hammer, the power source is me, or falling water, electricity, gunpowder, whatever it happens to be, that the machine is going to do something and it's going to have a power source which it's going to consume in order to do that doing that the machine does. So in that sense, it's going to be kinetic for sure. Potato, I would like to know more about smart TVs and coding. Well, okay, that's definitely. Well, I mean, I don't know much about smart TVs. I know the most important thing about a smart TV, though. The most important thing about a smart TV is don't give it your Wi-Fi password. Because it's not worth it. Whatever features the smart TV thinks it's trying to suck you in with, the amount of profiling of you that it's going to do, the amount of intrusion into your life that it's going to do. Oh my God. Did you see this? And I just saw this article, this thing about the Vizio smart TVs. I think it's Vizio, that have an automatic screensaver that comes on after the TV's been idle for a certain amount of time, and you can't turn off that feature. You cannot have it not do the screensaver, which wouldn't be so bad, except there's ads in the screensaver, like that. Now, if you're talking about coding, if you're talking about coding, programming coding, I'm happy to talk about that. I need to drill down a little bit more specifically what topics would be of interest. If you're talking about information coding, like MPEG files and MP3s and how to compress stuff to send images to a smart TV, that's a different sense of this term coding, and I could talk a little bit about that, but it's not something that I'm super brushed up on. Bert Tarter, I've just started a little exploratory project of my own. Great. Eager to learn more about your approach to join the Discord. Great. Learning about Heavy and learning and Hopfield networks. Great. there's no substitute for implementing it yourself. This is one of my mantras, and which is why it's so embarrassing that I went half a century without ever really implementing a fourth like language myself. I mean, I've implemented reverse Polish interpreters and stuff like that. So it's a gray area, but I always felt like that was a hole in my education, a hole in my skills, and it still is a hole in my skills because Nafi is not a fourth interpreter. Uh, um, but Hebbian learning and hot field networks. Well, hot field networks are close akin to the Boltzmann machine, which is close to my heart because it was, the first big research project I was involved in back in the 80s. Uh, um, I'm not doing machine learning right now. Sort of do that. And that's puts people off of the T2 tile project. And I think they're less interested in it because they say, "Oh, you just engineered it," as if that's trivial. But with the constraints of indefinite scalability and only best first reliability, it's not trivial. And I think in the future it'll be a lot easier because we'll have learned a lot more stuff about how to make grids and gradients and signals and do all of this stuff. And, we will learn the lingo. We will build out the body of knowledge, the software engineering body of knowledge of robust first models. And it won't be exactly the same as the movable feast machine, but it will carry over. The underlying learnings will carry over in some useful way. That is my belief. And so great. So, I won't be talking much about learning stuff. There is one T2sday update where I implemented Psi, which is kind of a neural networky algorithm, but it's not traditional learning. It was an algorithm from my PhD, again, back in the 80s. I'm not sure which episode it is, but I bet somebody knows. Okay, so making computers connect non-self, creating other organisms, having some aspects of yourself. Yeah, that's true. I mean, again, if they're arrangements of matter that have a power supply and they do something that's useful to somebody, that's the recursive definition of life, then that thing is life. And high speed. Beevee does not have access to the quantum tile layer beneath. Correct. But could draw on the ball plane. Yes, assuming it can localize. What's the context of writing the environment writing to the grid? So, high speed. If you mean literally quantum events, the physical layer under of the tiles that are made out of, after all, chips and fiberglass and wire and copper and so on. Javier Murad, another new voice. Thank you so much for speaking up. So I mean, Beevee could have access in an extremely limited sense because the movable feast machine provides a pseudo-random number stream to each tile. Each tile has its own independent pseudo-random number stream, which officially can be a real random number stream. Again, I kind of reject that distinction a little bit, but it wouldn't matter because there is no global seed. And this is one thing that makes people's heads explode a little bit if they're, computer programmers, developers. You cannot rerun a Beevee simulation and get the same results. I mean, not even on the T2 tiles you can't do it, but you cannot even do it on the MFMS simulator. There is no global seed because the individual simulated tiles that we see are running on separate threads in C++, inside of a multi-core processor, whatever it is, and they are not running in lockstep. they're grabbing locks between each other, and who wins a lock and thereby gets an event versus the other one happening to grab the lock, and so it gets events, and the course of the computation varies, is inherent. It can depend on anything. It can depend on quantum events. But, to try to think of a way that you're going to take use of that, you're going to do anything with it, not going to happen. Potato, why don't give it my Wi-Fi password? Well, so you said smart TV. Google TV Streamer, that's one of those little plug-in things, right? Those are different. Those are not smart TVs. Those are just little streamer things. So I hope that because we have one of those little dongle things that we stream with on our TV, but the TV itself does not get the Wi-Fi password. They all want to now, and we have to say no, no, no. And is the Google TV Streamer 4K safe? It's safe until it isn't. But I think it's a lot safer than giving the Wi-Fi password to the TV itself, which has microphones, it has all kinds of stuff to listen to you. Mario, hi, thanks for checking in. SciSpeed, smart thermostat creating local hotspot. Yeah, right. Again, I'm with the idea. I guess assuming that the quantum layer of your universe is the tile layer, I'm wondering what correlation can write down. Into reality, non-random. I'm still struggling to understand your point. I'll take a stab at it, SciSpeed. But if by quantum layer you mean the ground layer, the farthest down that you can go, something like that, then I'm not sure that there is any layer short of the Schrodinger wave equation down at the nuclei and atoms of literal physical protons, neutrons, and so on. There's no strict isolation. That's one of the things that determinism makes us think there is, that once we have a deterministic execution layer, once we have a deterministic execution machine, then we don't have to care. We cannot see anything, any properties of the physical system below the deterministic layer, except by using a stopwatch or, laser beams or heat guns or something like that to mess with it. But as long as we stay within the computational framework itself, except possibly by timing, if we had a way to do that, we're not going to be able to see through it. But we give up on that. We give up on determinism. So the fact that one tile gets an event before the other may go all the way down to literally a quantum event. I don't think it typically will. I think it's swamped by much more obvious macro scale events. For example, like the tiles can change their clock speed, and they change their own clock speed in response to their own temperature. So adjacent tiles may be running, one might be running at 600 megahertz and the other one's running at a gigahertz. And so the one running at a gigahertz will win more races to acquire locks than the one that's running at 600 megahertz. And we just let that happen. We just let it all flow out. That all flows up to the software layer. There's no isolation from the bottom of physics to the computational layer. Okay, leaving for good. Okay, Mario, best of luck. Good luck to you. How long does the T2 project exist now? Well, the T2 project videos have existed since 2018, so that's 7 years. But the research effort goes back at least, I would say, to 2008, something like that. The first, the Illuminato Ex Machina tile, which was a precursor to all of the T2 stuff. It was the T1 tile. That was 2008 era, I think, maybe even a little bit earlier. So the T2 tile project, in some sense, exists for 2 decades anyway, or say 2 decades. I can't imagine having the motivation working on a project for such a long time. I understand. uh, um, and I spent most of my career following my nose to say, well, that would be cool. Let's hack on that for a while. Well, okay, that's boring. No, well, hey, that might be cool. Hack on that for a while, and so forth. Uh, um, but along the way, I got to this realization of the problems of CPU and particularly RAM and the problems of deterministic execution. I mean, I was doing computer security, and I got absolutely frustrated to despair at the hopelessness of trying to do computer security in any kind of believable way. And I tried blaming everything. I tried blaming the users. I tried blaming the software. I tried blaming the programming languages. Tried blaming specific chips bugs and stuff like that. And none of it stuck. None of it really felt right. And the culprit was the architecture. CPU and RAM and deterministic architectures are inherently small systems. You scale them up, you will break. They will break. They will be insecure. They will not do what they're supposed to do. And they will therefore, since they assumed they could do what they were supposed to do, they didn't give a thought to they have only the crudest thought of recovery when something goes wrong, like reboot. Now, you get into network systems, you get into distributed systems. That's much more what we're talking about. And one way to view this, I used to talk about these kind of architectures, indefinite scalability, as like an internet in a box, a personal internet in a box, where it would all be doing stuff for you, but it would be doing it in a distributed fashion with different stuff coming and going and extra copies of things and competing and cooperating, all that kind of stuff, to get a job done for you in a robust way instead of the one gigantic master control program that's supposed to do everything perfectly. My problem is I find something more interesting than my current project. Me too. I hear you. I've spent tons of time. I mean, eventually, I spent all of my youth, my undergraduate, and much of my graduate school and much of years after that as well, doing little one-off projects, just trying stuff that I thought would be fun, I thought would be easy, and they either were fun and I got bored, or they weren't nearly as easy as I thought and I got bored, like that. SciSpeed, follow up on Discord. Thank you. Yeah, we would need to see. I mean, we could even try to find a time for a chat if we wanted to do that. The slope-shaped box by Google, not the Chromecast. Okay, you're ahead of me on Google TV hardware. I don't know about the slope-shaped box, so I don't know. I mean, what I would want to know is how much sensory stuff has it. So the Google box, does it, for example, respond to spoken commands like Alexa? I suppose it probably does. Hey Andrew, thanks for making in. And so would need to know how worried I would be about the slope-shaped Google box versus just the dongle. And reasonable fist machine. It's like robust first, but it's reasonable fist. Like that. How old am I? I am not yet 70, but I'm getting close. How old are you, Potato? Parameterized arch nemesis. Arch nemesis is the reasonable fist machine. I'm not sure what arch nemesis is in this context. This is great. All this conversation. Thank you so much, folks, for being willing to chat up. Architecture, arch nemesis, architecture. Oh, I see. Yeah, I am consumed by ideas about architecture. That architecture is the parts of a machine that change the least. And therefore, people run the risk of taking them for granted because every house has a kitchen, every house has a bathroom or whatever. So thinking about, do you need a kitchen? Do you need a bathroom is very unusual. And that's the point. The point of an architecture is it fixes a whole bunch of things that so you don't have to reinvent them every single time. But if there are limitations to an architecture, and there always are limitations to an architecture, Foib, thanks so much for coming in. Thanks so much for chatting. Yeah, we're almost to the top of the hour. I'm going to have to wrap it up too. Gemini features, I hear, and Google Assistant. So I think I would be terrified of having the slope Google box in my house because I would, I don't know if I'd be terrified, but I wouldn't choose it. Put it this way, I don't need it. I don't even know. I think we might have 4K TVs, but we rarely have even 4K material. And, to watch a movie once, it's okay. So I am a curmudgeon. I am a late adopter on a lot of new technology, as well as, the whole Internet of Things, IoT. To me, that sounds like a terrible idea because why? CPU and RAM will never be secure. You're inviting these CPU and RAMs into your home, putting them in your dishwasher, putting them in your fridge, putting them in everywhere. And then it's just a matter, it's, you're depending on the kindness of strangers. And that's fine until it isn't. And it often isn't, pretty quickly. All right. So who else? What am I missing here? That's why most of my projects die after about 3 months. Again, I hear you. And, just to finish the story, that it seemed that trying to fix CPU and RAM was going to be so hard, and so few people were working on it, and so few people even saw the problems in the architecture, that I kind of took it as my mission in life. I kind of took it as, okay, this is what I'm going to do with the rest of the time that I have. I'm going to try to move the ball as far down the road to make it clear that there are problems which are, properly speaking, laid at the door of CPU, RAM, and deterministic execution, and that they can't wiggle out of it with, I'll use triple modular redundancy and everything will be fine. No. CPU, RAM, and deterministic execution has got to go. It's a property. Only CPU and RAM and deterministic execution is only good for small systems that run for short periods of time. And we want systems that scale up. We are using these things that don't scale up. We are scaling them up, and we are getting the predictable consequences. $500 billion of ransomware last year or something. I don't know. I'm making up that number. But everybody explains it away. It's another frog boiling thing, even though the frogs don't do that. And if you install Android TV 14 on my broken tablet, will it work? It's using a MediaTek processor. I'm sorry. I do not know. For one thing, I would say it kind of depends on how broken the tablet is. I've only had one tablet in my life. I bought a early generation Amazon Fire or something like that. And it fritzed after like a week or two. I don't know. It wouldn't boot anymore, and I could never get it to do anything. And so, okay. So I don't have a lot of experience with tablets. MediaTek I've heard of. I expect they're either they're ARM processors or they're x86 knockoffs. I don't know. And Potato is a Debian old release. That's true. But I suspect our Potato here right now may not be talking about Debian releases. And Okay, so the screen is broken. Okay, but you can connect via network. You can SSH into it. Is that something that you do? You can connect to the machine and run command line stuff on it. I mean, again, I don't even know how programmable tablets are these days. Uh, um, Certainly, we've got lots of old laptops lying around. A lot of them are running something or other, running the colored lights around the house, or running our little servers and so on. That we don't care about the screen for these things because we come in by the network exclusively. So maybe. But I admit this is one of many areas of technology which I am seriously non-expert in. And all right, and okay, so why don't we call it for now? I haven't seen too many April Fool's jokes so far, and that's good. I think I may get off of the social networks for a while. Anyway, I mean, I got to get some sleep and everything now. So, okay. Well, folks, thank you so much for coming here live so that we can have this kind of stuff. Keep coding, Prof. Thank you, SciSpeed. I am going to. Uh, uh, Looking forward to see you in code relevance realization via locality. Okay. Me too. Let's figure out what it is together. Let's figure out how to implement it together. And cheers, Gert. I'm gonna call you Gert Tractor because now I'm an insider. Okay, Mario. Best of luck with your ventures. And all right. Okay, guys. Now we all have to be nice. The first rule of the first FedI Council priority is spirit before name, and that means doesn't matter who we are. We have to practice good spirit, and I trust we are all doing that. Okay, I'm going to end the chat now to end the stream. Thanks so much for all the interaction. Yay. See you next month. All right.